Hello, everyone. Thank you for joining in today. My name is Ashwini Dashgupta, and I'm here to discuss with you some of the opportunities and possibilities with research in mathematical sciences at Cheenta, and how they can affect your academic career. So, we will be breaking up this discussion into two segments. First one is what kind of research is going on at the moment at Chinta, what students are doing, and what the faculty members are helping them with. And the second part is how they can be useful for you in the long run and why you should be engaging in projects like this. So, there are about six projects going on at Chinta right now. Some of them are done by school students, and some of them are done by college students and university students. I can tell you about one kid, Chinar Deshpande, who is working with one of our faculty members, Sharnav Jumhomik, on computer vision related project. So this has been over 5 6 months, or maybe a little bit more than that, and they are trying to use artificial intelligence, neural network, machine learning, stuff like that, and build models that can help with autonomous driving and build and compare existing models that are already out there. It's a very exciting project. Chinar started when I think he was in grade 9 or grade 8, even grade 8, I think, maybe grade 9. And then this has been going on for quite some time right now. I think another student, Harshita, is also working on the same project, also another school student. Both of them are working with one of our faculty members, Sharnav Jobhomik. Sharnav Jo is himself a published data scientist, computer scientist. He has been working with computer vision for quite some time. So I truly believe that their project will be really nice down the way. The second project that I can talk to you about is also done by school students. It's students of grade 9 to grade 11. They are working with me personally. It's the project is known as freeze groups and freeze isometries in Indian temples. So what we are working, there are 5 6 kids out there, ninth graders, 10th graders, 11th graders, and so on. What we try to do is that we analyze the pictures and the architecture, and through that the architecture of temples in West Bengal. There is a place called Bishnupur in West Bengal, and we try to analyze the architectures using tools from group theory. So group theory is a part of algebra which helps people to understand symmetries of certain objects. Symmetry means if you move an object after, let's say you move an object by 2 centimeter horizontally to the left, and after you move it by 2 centimeters, it looks exactly the same as it was looking up before. Like whatever it was looking earlier, it looks exactly the same way after you move it by 2 centimeters. Suppose that happens, then that moving left by 2 centimeters is a symmetry, and we can study such symmetries using tools from group theory. There are certain one dimensional symmetries known as freeze symmetries. And our group, the 5 6 people who are there in that group, we are actually pulling up data from the Bishnupur region of West Bengal and analyzing the temple architecture, and we want to categorize what type of frieze isometries are available in the in that particular area. So that also tells us a very interesting story about how mathematics and architecture evolved in Indian subcontinent. This sort of studies have been done in other parts of the world, in Europe and in Americas, but up to my knowledge, such study from a mathematical standpoint has not been done in Indian subcontinent, which is very interesting to me. Talk to you about another project that college students and some pre-college students are working on. This is on hyperbolic geometry. You know that there is Euclidean geometry which we study in schools, which satisfy the fifth axiom of Euclid, that is the Playfair's axiom. What the Playfair's axiom says is that if you have a line and if you have a point outside that line, then there is only one line that is possible that passes through that particular point and never touches this particular line. So only one parallel line is possible to this line through that point, external point. This is the fifth axiom of Euclid. Now, there is a geometry out there which does not obey this fifth axiom of Euclid, and that's known as the hyperbolic geometry. Through a point outside the line, infinitely many lines are possible that pass through that point and do not touch this particular line. That's hyperbolic geometry, and it's possible to understand a hyperbolic geometry using groups. My favorite part of mathematics, the one that I did my PhD in, is called geometric group theory. It's a confluence of geometry, group theory, hyperbolic geometry, topology, all sorts of nice beautiful things. And this particular project, the one that I'm working with some high school students and mostly college students, is focusing on certain kinds of group action on some certain kinds of hyperbolic metric spaces. If you don't know what those words mean, do not worry about it. You can go to the links in the description to check out the detail of this project. Finally, I want to talk to you about the fourth project. It's on geometry group theory again, but it's related to an embedding problem. So there is something called the hyperbolic surface, and there is something called relatively hyperbolic groups. We are interested to understand, this is an open problem for, like, let's say 10 years now, 10, 12 years. We are interested to understand whether it's possible to embed hyperbolic plane in relatively hyperbolic groups. Now, part of this problem has been solved by McKay and Sisto, I think 10, 12 years ago, but they had some extra conditions which we would like to remove and prove this problem in greater generality. And there are in this, but this is a university level project. So students who are doing masters or doing PhD, they are involved in this particular project. So it's very exciting because our dream at Cheenta is to train for Olympiads and contest mathematics, and then use those skills that we have to do research, to find out new things, to ask new questions. And that is what is exciting. If you build something for the first time in the history of humankind, whatever little thing it is, that's pretty exciting, right? So that's what we want to go. That's the dream of Cheenta. We train people for mathematical Olympiads, physics Olympiads, CS Olympiads, and then those skills come in very handy when you go and do great research projects. You find out new things. That is exciting. That's what we want to do. Now, the other part is how these research projects will be useful for you. So there are a couple of things that will happen. When you are doing research, you're asking new questions and you are learning a lot of things to solve an unsolved or untouched problem. So students are automatically motivated to learn new things. One of the things that parents tell us a lot of times is that, okay, my kid is smart, but he's not motivated only if he sits with the mathematics or the problems. So motivation is a very important thing. And one thing we found out while doing research project with kids is that if you are searching for the unknown, that's an adventure, and the children become very motivated to learn new things, and they often do it by themselves. They find out things. Nowadays it's internet is everywhere. You can access books, you can access material It's everything is out there. You just have to be motivated and do it. And that's where these sort of projects are very helpful. So that's one way research projects can really be helpful. The second thing that is also very important to keep in mind is that suppose if you are looking for jobs, or if you're looking for a great university to go into, let's say you want to do a PhD or a bachelor's or your master's program in some big university in India or United States or Europe or somewhere else like that, research projects can be a very strong addition to your resume. It can really help you to get into some of those best places in the world. This has happened over and over again. We experienced that with recently. We experienced that with Aryan Kalia, who built a research projects on graph theory and mathematics, and then went into he is now in Harvard right now, and join the mathematics program out there. So multiple factors actually play a role in this sort of processes, but we do think that research projects can be a very strong, like an addition to your resume. So it's a great learning opportunity. It's a great addition to your resume, and it's awesome to build something new which no one did before. Maybe it's a small problem, but even that small thing is happening first time in the history of the world, which is fantastic, right? Now I want people to ask questions, so you go ahead and write in your questions in the comment sections if you have any. But I'll just add a couple of things. The culture of asking question is more important than the sometimes can be more important than the question itself. There was a great quote by Gabor Szego. He was one of the greatest mathematicians of the previous century. He said that, I mean, I'm paraphrasing here, that why will a child sit with a problem for hours? It's a considerable intellectual effort. Why will a child do that? Or anyone do that? So he says that it's more of a cultural thing, that you value intellectual and spiritual happiness more than material happiness. So that is a very important factor when you are involved in something like research. Whatever little thing you are thinking about, that's happening inside your mind. That's an intellectual effort, and it makes you happy. And I think that is a third important reason why someone should be doing this. I have a question here from, I think, Cube Coder. So, sir, can research projects contain a topic other than maths? Of course, they can. I'm just talking about our expertise at Chinta. We have people who work on mathematical sciences, so mathematics, computer science, data science, artificial intelligence. But of course, you can talk to your teachers, you can go to nearby universities, you can do awesome projects in physics and chemistry, even in social sciences like history or geography. Uh, everything, wherever, whatever interests you, if you are able to ask questions, if you're able to ask questions, and if you are able to find happiness while pursuing that question, that is itself a project. Of course, you have to be disciplined. You have to write down the things you find out, and you have to help get it published somewhere maybe. But that discipline and that progressive change. So one thing about research that sometimes people get it wrong, that suppose if you solve a complex math olympiad problem, you immediately get some happiness. Like you can get that happiness, that kick inside you every day. Like if every day you solve a good problem, you feel a little happy. That can happen every day. And the second, that is different from what happens in research. In research, in research, you can get that happiness like once in 5 months or 6 months, maybe once in a year if it's a complex problem. But that happiness is tremendous. I mean, you feel out of the world because you found something new that no one else thought about. It might be something very small, but that's very, very important. That's happiness is very important. Okay, So I have a question from Shrihan Suchit. He wants to know how can you research. So Shrihan, several you can ask your admin if you are in Cheenta already. You should have your own personalized WhatsApp group. You can ask the admin, and you can tell them that you want to do research, and there is a waiting list for the people in our groups. They can add you to that waiting list, and whenever something new comes up, you can always join it. So for example, I think the pre-college level project on this freeze isometries will be really good for you if you are at the pre-college level. I think you are, so if I remember correctly. So yes, certainly you can do that. You can ask your admin. Okay. So now I have another question: how to start a project, meaning how to find a perfect topic. Well, I would say, Cube Coder, I'll just say something like this, that I would try to find someone who is involved in research, you know, because it's a community thing. You find people who are asking interesting questions and trying them and thinking about them. I'll tell you about myself. I wake up in the morning before I come to the office of Chinta. I usually I sit down at a cafe or somewhere like that, and I take a cup of coffee and I think about a problem that is bugging me. Like I am thinking right now I'm thinking about a problem which is very much related to that embedding problem that I talked about. That hyperbolic surface embedding in a relatively hyperbolic group. So I'm thinking about that problem. So there are many people like that who are thinking about problems, who are thinking about problems day and night. Maybe they're not actively writing down things, but they're thinking about it. So I'm saying this, that in your around you, maybe in your locality, try to find someone like that. And I bet there will be people in universities or in colleges or some professor who would be very interested in this sort of thing, who likes thinking about problems. So once you get attached to a person like that, preferably in your location, look close to you, where who you can physically meet, that sort of association will be very helpful. Because until unless you have some person like that, you may start with an open problem or something like that, but might not be able to continue it. That's a problem. Any other question? Sorry about that. Okay, I see there are no questions as far as I can see in the chat. So thank you everyone for joining in today. I will be very happy to take more questions in the comment section. If you have more questions, please put them down, and keep on learning great mathematics and asking great questions, and having fun with it. Okay. All right. Take care. Bye. Oh, I see there is a one more question. Okay. I'm in class 11, interested in pursuing algebraic geometry in future. Okay. I think Shodayon sir has some experience with algebraic geometry. He works with algebraic K theory at Chanda, so he might be able to help you. Why don't you put your request in the personal WhatsApp group where multiple admins are there, and I'm sure they will be helping you with this. Okay. All right. Thank you. Bye, all of you.